In modern information security, the core concern is no longer just the algorithm, it is the architecture. Even when cryptographic systems are mathematically sound, poor implementation or operations can render them vulnerable. This is the fundamental premise of security by design, a philosophy asserting that security must be integrated into the system from the earliest stages of development. It emphasizes prevention through principle-driven architecture. The principle of least privilege serves as a foundational guideline. Users and internal components of applications should be granted only the minimal permissions required to perform their tasks. For instance, if a web server process runs with root privileges, a single vulnerability can lead to full system compromise. By limiting privileges appropriately, the scope of damage can be effectively contained. Input validation and sanitization is another indispensable safeguard. Attacks such as SQL injection and cross-site scripting, in XSS, typically stem from inadequate verification of user input. External input should never be trusted by default and must be filtered against predefined schemas or whitelists. In cryptographic contexts, unvalidated inputs can lead to hash collisions, padding oracle exploits, or buffer overflows, each posing a significant risk. Key separation and isolation is also central to secure system design. Sensitive data such as authentication tokens, passwords, API keys, and private cryptographic keys should never be stored in plaintext or embedded in source code. Instead, these secrets should be handled via secure mechanisms like hardware security modules, key management systems, or encrypted secret stores. Cloud-based key management system solutions, such as those from AWS and Google Cloud, perform cryptographic operations without exposing the keys themselves. Security compartmentalization helps limit the propagation of breaches. By dividing a system into discrete, independently secured modules and minimizing interfaces between them, vulnerabilities in one component are less likely to affect others. For example, modern browsers implement site isolation so that content from different domains is processed in separate memory spaces, mitigating the risk of cross-origin attacks. Ultimately, security must be treated not merely as a technical feature, but as an architectural philosophy. Attackers will always seek out the weakest link. Even the strongest algorithm can fail in the face of careless input validation or poor privilege separation. Consistent application of fundamental security principles throughout a system remains the most effective defense against modern threats, such as side-channel attacks, key leaks, and hash collisions. Security by design is both the starting point and the practical framework for achieving this level of resilience. The next section will delve into how hardware-based defenses, specifically HSMs and TEs, form the backbone of secure cryptographic operations in modern architectures. It will explore their technical roles, implementation challenges, and real-world examples in cloud services, secure payment systems, and embedded devices.